Hi folks. So I googled up Haskell in order to try and learn it. This is its page on the web. All right. So what does it say? An advanced, purely functional programming language. So this is a symbol of. This is called lambda. It's a, symbol in the Greek alphabet. And why is it used here? Because the paradigm of functional programming uh, is largely based on the so-called lambda calculus. So we'll probably explore it maybe if we feel the need later. All right, so it's declarative, statically typed code. All right, uh, type help to start the tutorial. Let's see what does it do. Help. Uh, 5. So this is a web-based console. Yeah, well, let's leave it. Let's see what are its main features. It is statically typed. Every expression in Haskell has a type. Note that it's not saying that every variable has a type. Every expression has a type, which is determined at compile time. All the types composed together by function application have to match up. Okay. If they don't, the program will be rejected by the compiler. All right. Types become not Types become not only a form of guarantee but a language for expressing the constructs of the programs. All right, that's good to know. What does it say? And click to expand. Okay, let's first uh, take an introduction of all these features and then we'll expand those. All right, it's purely functional. Every function in Haskell is a function in the mathematical sense, that is pure. Even side effecting IO operations are but a description of what to do, produced by pure code. There are no statements or instructions, only expressions which cannot mutate variables, nor access state like time or random numbers. Okay, so basically what it's saying is that uh, the variables are immutable. Essentially, what it is saying is that a pure function always gives the same result when it's passed the same parameters. So this clearly would make it very restrictive. I think it does have advantages, but those restrictions it would have a way of going around or doing them properly. Because of course it's not possible to do any computation and not change state, right? That's not possible. So we'll see how it does that. Type inference. You don't have to explicitly write out every type in a Haskell program. Types will be inferred by unifying every type bidirectionally. All right. However, you can write out types if you choose or ask the compiler to write them for you for handy documentation. So this statically typed and type inference seem to be somewhat competing considerations, but we'll see. All right, concurrent. Haskell lends itself well to the concurrent programming due to its explicit handling of effects. Its flagship compiler, the GHC, comes with a high-performance parallel garbage collector and lightweight concurrency library containing a number of useful concurrency primitives and abstractions. All right, that's good to know. Lazy. Functions don't evaluate their arguments. This means that programs can compose together very well with the ability to write control constructs such as if-else just by writing normal functions. The purity of Haskell code makes it easy to fuse chains of functions together, allowing for performance benefits. Right, but having said that, what's the guarantee that you don't run up into errors, right? So we'll see. These are all, we'll see. Packages. Open source contribution to Haskell is very active with a wide range of packages available on the public package servers. Okay, that's good. Okay, let's explore each of these things separately. Now, statically typed, all Haskell values have a type. All right. So character A is a character, integer This is a nameless integer. It's a character. So this function is digit. Uh, this function is digit maps a character to a bool. This is what I understand. Okay, you have to pass the right type of values to functions, or the excuse me, or the compiler will reject the program. So is digit one will there will be a type error because it expects a character. You can decode bytes into text. So this is some bytes crypto SHA1 hash of a string hello is generated and put into these bytes. Excuse me. Text is equal to decode UTF-8, so it gets it gets transformed into UTF-8 coded text. Excuse me, but you cannot decode text which is already a vector of Unicode points, right? Okay, just hold on a minute. All right, so let's continue. It's purely functional, so let's explore that. Click to expand it. The following function takes an integer and returns an integer. By the type, it cannot do any side effects whatsoever. It cannot mutate any of its arguments. All right, so square is defined as a function that maps an integer to an integer, which means it takes integer as a parameter and returns an integer. And this is how it is defined. Square of x is equal to x into x. The following string concatenation is okay. Hello plus plus world. The following string concatenation is a type error. Name plus plus get line. Because why is that so? Because getLine gets an input from the user, and that once it is concatenated with name, so it is not so to say it does not guarantee this getLine function does not guarantee purity in a way, because it will always it has a potential to get a different string each time the input is taken, right? Okay, because getLine has type iostring and not string like name. So by the type system, you cannot mix and match purity with impurity. See, so that's what it says. All right. So we collapse this and go to type inference. All right. So let's see what does this do. So this example has a type signature for every binding. Okay. So this is a function main. I don't know how is it defined. Main IO. I don't know what does this mean. We'll explore this further. Main is equal to do. So do would have a y. Do. This looks like corresponding corresponding uh, do this do. Okay, so this portion is the do line string, get line into this string, print parse digit line, parse digit by digit this line and print it, where parse digit string is maybe int parse digit, then the parse digit is a function. What is it saying? And if digit c, if is digit, then just subtract something else to nothing. Okay, but you can just write main is equal to do line get line print parse digit line, where parse digit C equal to if is digit C, then do this function call and so on. So what is this saying? That the compiler is automatically inferring the types, right? You can also use inference to avoid wasting time explaining what you want. Do ss decode the string uh, is decode 123, return zip with whatever. Just I don't know what the head is this doing. Anyway, types give a parser specification for free. The following input is not accepted. Uh, so no, I don't understand this. We'll see this later. Concurrent. Let's see. Easily launch threads and communicate with the standard library. Main do done da da fork IO. The thread is being forked. I'm one thread. Blah blah. Second is forked IO here. Kill thread second message. Asynchronous API is present for the threads. Alright, so this syntax I'm not familiar with, we'll see this later, but we get an idea. Atomic threading with software transactional memory. Okay. Transfer amount, transfer from atomically. So it guarantees atomicity of operation. So as we can imagine, these things like atomicity and concurrent software, this clearly benefits from the pure functional aspect, right? Because if you know that no state is being changed, right? So as many threads you fire up doesn't really matter, right? So we'll see this later too. Okay, so lazy. Let's explore lazy aspect. Functions don't evaluate their argument. This means we have seen this. Define control structures easily. When PM is equal to if blah blah, main is equal to whatever the hell. I don't understand this syntax because I have not studied its syntax. If you notice a repeated expression like if C then T else false, you can give this a name. Ah, this is interesting. That this entire expression can be named and then use it with the same effect as the original expression. This is interesting. Okay, so this what is this? This is in a sense a function, right? Without it seems something like a function, right? We'll explore this. All right. Get code reused by composing lazy functions. It's quite natural to express the any function by reusing the map and or functions. Any da 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 any p or dot map b. Reuse the recursion patterns in map filter folder, etc. So we'll see that. So it has a package ecosystem. There are these numbers of packages available. All right, we'll see them later. Okay, so what do we do now? So what do we do now is we try to download it. All right, let's download it. All right, downloads. This page describes the installation of Haskell toolchain, which has 4 elements: GHC, Cabal install. Okay, let's do one thing at a time. All right, this is the actual compiler. The latest release is this. Let's download it. Okay, version blah blah blah. If the package is only for the most, you're installing a proper Haskell distribution. A distribution includes a recent GHC release as well as other important tools for installing this. Okay, GHC is an optional code generator targeting the LLVM compiler framework, which can produce faster code. If you would like to use LLVM, so let's try to see the proper distribution. All right, so let's see for on Windows. Install GHC via Chocolatey. Whatever the hell is that? Let's see, Chocolatey. So what is this Chocolatey? Um, Overview. Let's see what the hell is this. Chocolatey is a software management solution unlike anything else you've experienced on Windows. Chocolatey brings the concept of true package management. All right, so this is something like a package manager like RPM or Yum or stuff. Okay, so let's install this. Uh, Install now. Okay, installing Chocolatey. Subscribe, no. Choose your installation method. All right, PowerShell, .NET Framework. Okay. First, ensure you're using administrative shell. You can also install as a non-admin. Uh, Alright, so let's open up a PowerShell command, PowerShell instance. So it is restricted. It is saying. Alright, we suggest using bypass all the sign provided. Run get execute policy execution. Then run set execution policy. All the sign blah blah. Uh, okay, so let's run this. Set execution policy. All signed. Okay, so where did this go? Here is the PowerShell. Let's execution policy. Execution policy helps protect you from scripts that you do not trust. Changing the execution policy might expose you to security risks. We want to change. Yes, we're making it. All signed is more secure. All right. Access to registry key. Blah blah is denied. We're not administrator. Okay. Wait. Let us run this as administrator. Okay. Yes. Let's do this again. Yes. Alright, it's done. And then it is saying that we run this bypass scope, blah blah blah, whatever. Let's copy it and run it. Alright, so what is it really doing? What it's doing, set execution policy as bypass, scope process level, force, security protocol is something like this. Object system download string. So apparently it is giving some access to its own URL of chocolatey. Okay, let's let it do its magic. So it is installing the local machine. What is it saying? Warning, not setting tab completion. That should not be a big deal. Okay. Anyways, paste the copy and wait a few seconds. If you don't see any errors, you can type choco or choco this. Okay, let's see. Where did it go? Here it is. So let's say we type choco. Alright, choco is installed. Good. Can we see it on a uh, non Windows shell as well? Okay, non PowerShell shell as well. If it has put in the path, it should be available. Yeah, it is. Alright, so Choco is installed. Let's go ahead. Advanced and blah blah. So this is done. Let's go back. Where were we? We were over here. GHC. Alright, so configure chocolatey at an elevated Choco install Haskell dev. Alright, so let's do Choco install Haskell dev on the PowerShell. So it's downloading it. And after that, we'll see what else it does. After that, it is saying that we have to run refresh environment. And after that, there is something called stack. We follow the instructions here. Let's see. What are these instructions? We recommend installing to the default location. With these installers, it will make stack install and stack upgrade work correctly out of the box. You will see a Windows Defender Smart Screen. Okay, manual download. Download the latest release, unpack the archive, and place somewhere on the path. Alright, installer script curl. Ubuntu, OpenSUSE, blah blah. So many options. Okay, so I think this curl command should work over here as well, right? Where is this? This should this should run. Let's say this should run in the PowerShell. Uh, so what does it say? Do you want to run the script? Cabal is approved. Blah blah. Performing other installation. Yes, go ahead. Okay. Okay. So after this is done, we will look into what to do with stack. Okay, so we'll do a refresh environment. Okay, what is it saying? Choco, do you want to run the script? GHC, blah blah, yes. You want to. Alright, while it's downloading it, let's see. So this should ideally work, right? So this installation script get haskell.org, and we ask the shell to execute it. Hopefully it should run. Um, and this manual download appears simple enough. We can do this too. Let's see. So this is downloading its stuff. Till then, let's download this too. Let's do it manually, okay? So let's download this stack, and let's just put it in the path wherever Haskell is installed, and we should be ready to go. Okay, so this is downloaded. Let's see the status of the PowerShell. It's still downloading its stuff. So while we wait on it, let's okay, so these are the install options. Alright, okay, yeah, well, so this is fine. We just close this, we go back, and we go back from here, and now we go to the documentation. Alright, let's go to the documentation. Alright, so documentation, books for learning Haskell. So there's lots of books. You know, let's this sounds like a good book. Let's see if it is available for free or not. Alright, Haskell, the Craft of Functional Programming, 3rd edition, blah blah blah. Existing material has been expanded and reordered. Okay, contents, preface, changes, start. First, you need to install the Haskell platform. Okay, so this is probably its own examples, links. Alright, so yeah, this is not free. So anyway, we'll at this moment we don't want to buy stuff. So let's see, there are some courses. Let's forget the courses as well. Short, dense, classic ways to hit the ground running. Yeah, this is the kind we like. Alright, so This area is, this is probably what I would want to do. And there are some online resources: Haskell Wiki, Haskell Wikibook. Okay, so this looks good. What I wish I knew when learning Haskell. And this, let's see, what is this Wikibook? Wikibooks are usually free, and there are manuals and guides. User guide for all of these things: package and dependency management. There is library management, and then there's some language report. All right, so let's see, what is this Haskell Wikibook? Okay, what does this guy say? Haskell is functional programming language, blah blah blah. So can we see a table of contents of this book? Uh, what is this guy saying? Okay, beginner's track. The section introduces you to Haskell basics and commonly used libraries, blah 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 blah. Yeah, this thing seems like a good thing. Then there's advanced track. Okay, okay, Haskell in practice. Day-to-day issues of working with Haskell include these things. This looks like a good book. This looks good. Not bad at all. Uh, okay, and these are they seems like good things too. Let us see them. Learn you a Haskell for great good. So it's probably not the best uh, in grammar, right? But this, I don't know how good this book is. Let's say starting out. Okay, what is it saying? You're the horrible person who does not read it. Introduction to thing, blah blah blah. Yeah. So this seems like our kind of stuff. Okay. So this looks good. Real world Haskell. All right. So this is published by O'Reilly. Okay, O'Reilly usually publishes very good books. So let's see the aspect which is available online for free. Why functional programming? Blah blah blah. So this might be a good book too. We'll see. But now we just follow one book and let that be this one. Rather, not even this one. Let's let's let the wiki book be the book, right? Okay, so let's see the progress. Okay, so yes, do go ahead. So it's trying to do some of its installation magic. Meanwhile, let's see the book. Okay. All right. So manuals and guides, blah blah. Let's go back up. Tutorials, gentle introduction. Yet another. Right. Write yourself scheme in 48 hours. This looks like a good thing. Write yourself a scheme 2.0. Okay. Let's see what are these things. Short, dense, classic ways. Yeah, they seem good because for people who have all right, write your scheme version 2, posted on blah blah, overview, introduction, parsing, transformation, blah 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 blah. This so basically what it is doing is that it is writing a scheme interpreter. Scheme is in another language. It's probably a dialect of Lisp in Haskell, right? Let's see. This seems like a good thing. Okay, this seems like good stuff. Let's keep it bookmarked. And here is another one: write yourself a scheme in 48 hours. Okay, so Jonathan Tang has written it. Who is this guy? This is Adam Westpisser. Okay, uh, is he the same guy? Yeah, Adam Westpisser. All right. Okay, so these both of these we should these look like my kind of things. Okay, we'll use these. And in addition to this, when we need to be able to find a reference manual or something, we should be able to consult the documentation on main Haskell webpage. Let's see that. Do they have anything like a Haskell book or something? Uh, 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 Tutorials online. Is it an official documentation? Here we are. GHC user guide. How to write a Haskell program. So we have a GHC, which is its compiler, Glasgow compiler. We have a guide of that. Uh, so what is this thing? I was just clicked something at random to see what does it, how does it explain things. All right. So yeah, this seems like the 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 book style introduction, right? Okay. Okay, let's see what else is out there. Okay, so how to write a Haskell program. Let's see. So there's ample documentation. Wiki.haskell. Okay. So revision control, blah blah blah, testing, structure. Yeah, so this is just a broad term, skeletal, basically a guide to giving a skeletal program structure recommended. So that is not what we are looking for. Okay, so introduction to Haskell. Okay, learn your Haskell. Great, good. Okay, real world Haskell. Yet another tutorial. Haskell Wikibook. Alright, usage scheme and how to learn Haskell. Okay, about Haskell by human language. Other tutorials. So some of these are. Alright, so there's tons of stuff. Okay. Alright, so we cannot explore all of these obviously. We'll just see something and then keep on learning ourselves. Alright. So this is a recommended tutorial. Let's see what does this guy say. So this is some lectures from University of Pennsylvania. Uh, Introduction to Haskell, algebraic data types, blah 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 blah. So let's say if we at random, if we just see this lecture. So recall our simple definitions of blah blah blah, map, filter, polymorphism, this, that. I mean it's all the same, so we should be able to rely on any one of those and just move forward. Okay. Uh, let's go back. Okay, so all right, so that scheme thing looks good to me because that would force us um, to basically um, learn it in depth, right? So let's see where did that PowerShell go. All right, so it's done. We should do a refresh environment, and it has done it. All right, so uh, all right, so what else? We had to save, we had to copy this stack.exe to see tools where it has installed GHC and stuff. And if I expand it to if I unzip it over here, all right, so this is, so I can add this path to my environment variables. So let me add that to path here. Alright, so here we are with path. Let's edit it. Let's add new. Let's add this. Okay, and let's apply it. Alright, so basically what I have done is I have added the path, and if I run stack over here, I should be able to, because it's in my path now. Yeah, it is. Alright, this sounds good. So if I try to run Haskell interpreter, what is its name? GHK? What was its name? Let's see. So I guess for this introduction, uh, we have successfully downloaded and installed the Haskell, and we are ready to dive deeper to start writing code, and we'll do that precisely in the next video. All right, have a good day. Bye.